In this lecture, we'll look at fancy indexing. Fancy indexing means indexing using integer arrays. Let's create an array and see what this fancy indexing is. So I'll save my array in a variable called array1, and we'll use NumPy's empty method to create an array. Let's create a 12 by 5 array. Okay. Now we can use a for loop and say for x in range, let's say 12, we can index our array1 object at index x, and then we can set it to be equal to x. Now if we call our array1 object, we have an array of, so the first row is an array of zeros, and then 1, 2, 3, and so on. From this array object, what we can do is we can select a specific row in any order that we want by passing it as a list of array. That's what fancy indexing is. For instance, I can grab a list of this array containing, let's say, all these 2s, 4, 6, and 8. So how can I do that? I can simply, all you have to say is array1, that's our array object, and then pass the rows that we want to grab. So in this case, we want to grab the row containing 2s, the row containing 4s, 6, and 8s. So we pass those as a list in our array. So if we run this, now we have a new array containing the elements, a list of elements 2, 4, 6, and 8. Similarly, we can grab array1, and then we can pass a list containing whatever we want to grab. Let's say we want to grab the rows containing the 2s, 3s, the 10s, and 11s. So we can do that. We can also pass negative indexing. Here we are using positive indexing. We can also use negative indexing. So basically that will grab elements starting from the int. For instance, we can say array1, and then if we want to grab just the last row, which is the row containing 11s, we can simply pass a list containing negative 11. I mean negative 1. So that will give us all the 11s. And if we want to grab the rows containing, let's say, 10s and 8s using negative indexing, we can say array1, and then we can pass a list. So this is negative 1, negative 2, and negative 4. Negative 2 and negative 4. That will grab the rows containing all the 10s and 8s. Let's run this. So we have the row containing all the 10s and 8s. Okay, let's create another array and show you some more of this fancy indexing. And I'll save my array in a variable called array2. We'll use the arrange function, NumPy's arrange function, to create this array. Let's pass 40, and then we'll call the reshape method on it. and we'll reshape our array to be an 8 by 5 array. So it will have 8 rows and 5 columns basically. So if we call our array2 object, we have 8 rows, 1 2 3 4 5 6 7 8, and each row has 5 elements, 1 2 3 4 5. So that's the reshape method. We can call the reshape method on our array object. Now what I want to show you is, let's say I want to grab the elements. For instance, I want to grab 5 and 11. How can I do it? For this case, we can pass this array2 object and then pass 2 lists. The first list will grab the outer level. For instance, if I want to grab 5 is in the second row, right? So the first list will grab the row where the element is, and then the second index or list will grab the element 5 from the second row. Okay, let me show you. So we have our array2 object, and we want to grab 5 and 11, right? So 5, so we'll pass 2 lists like this. So the first list will grab the outer level, which is the row, which row the element is located, and the second list here will grab or extract the element from that specific row. So 5 is in the second row, right? So that will be index 0 1. So that will be index 1. And how about 11? 11 is in the second row, so that's index 0 1 2, index 2. So we took care of the rows. Now in that specific row, where is 5 located? So 5 is at index 0, so we'll pass 0 here, comma, and we also want to grab 11, right? So here 11 is at index 0 1, so 11 is at index 1. Now if we run this, we'll get an array containing the elements 5 and 11 as a list. Let's run it. So here you see we have 5 and 11. Let's look at some more examples to clarify this. Let's say we want to grab 27, 33, and 39. So we want to grab 27, 33, and 39. So let's look at 27 first. So 27 is equal to, so 27 is in row, let's see, 1 2 3 4 5, it's on the 6th row. That means index 0 1 2 3 4 5. So 27 is at index 5. Index 5 means the 6th row, and then within that row it's at index number 2, right? 0 1 2. So we'll put 2 for 27. Now let's take care of 33. So 33 is equal to, let's see, 33 is at index, so this is index 0 1 2 3 4 5 6. So it's at index 6, and within this row 33 is at index 0, 1, 2, 3. So index 3. And finally, let's take care of 39. And 39 is equal to the last row, which is index 7. 0, 1, 2, 3, 4, 5, 6, 7. And then within the last row, 39 is at index 0, 1, 2, 3, 4. 4. Okay. Now let's pass these values in our array2 object as a list. So in this case, all we gotta do is array2. We have done most of the work. The next thing we need to do is pass those lists. So as we have seen before, we need two lists. One is for the outer and the second list is for the inner. So the outer ones are 5 for 27, 5, 6 for 33, 6, and 7 for 39, 7. And for the inner index, we have 2 for 27, 2, 3 for 33, and then 4 for 39. So when we run this, it will give us an array containing the lists of 27, 33, and 39. So we have 27, 33, and 39. So this is what I wanted to cover in the fancy indexing lecture. So as we have seen in the lecture, fancy indexing means indexing using integer arrays.